Hey everyone. In this video, I wanted to address a question that's actually coming up more and more frequently. And it's really, what's the difference between using Microsoft peering over ExpressRoute to access Azure PaaS services compared to private peering with a private link endpoint? So in this video, I'm just going to go over what both of those things actually are, how they work, and then hopefully you can understand the difference between them. As always, if this is useful, a like, subscribe, comment, and share would be appreciated. Okay, so if we think about Azure, as we always talk about, Azure is made up of regions. So I'm going to think about, hey, I have a particular region, and there are lots of them. So there's lots of regions all throughout the world. Now these regions are connected, remember, to that great big Microsoft backbone network. So we always have kind of these redundant connections from each region, and these regional network gateways that connect us to that backbone network. And this Microsoft backbone network is one of the biggest networks in the world. Now, in addition to connecting to the Azure regions that host things like Azure and Office 365 and Bing and Xbox, they also extend down to a large number of kind of edge locations. You might call them kind of POPs. But again, lots and lots of these edge locations have that Microsoft network extended into those as well. Now, at those edge locations, they do a number of different things. One of them is to actually go and connect to other carrier networks. So I could imagine, for example, hey, that might be kind of AT&T. They have a network, so Microsoft connects to that network at various kind of points and presence. You might imagine that also, hey, look, maybe Verizon. And there's lots and lots of these carriers, but again, you can kind of think about Microsoft connects to lots of these different carriers at those edge locations. It tries to have a direct one-hop connection to all of the major carriers. And that's what the internet is, remember? The internet is just, hey, at certain points, all those different carriers come together. You might hear them called these carrier-neutral facilities, fiber hotels. That is what the internet is. All the different carriers connect together over this controlled IP space, so there's no overlap. And then that is what the internet is. So that's great. So Microsoft connects at certain locations to all the different carriers to give Azure and other services basically internet connectivity. Now, we then have lots of services in Azure. So I could think about, well, I'm going to talk about storage a lot, but this applies to really any of the PaaS services, be it Azure SQL Database or Cosmos DB or Azure Migrate, the list goes on. But essentially what you have is the idea that, well, I have a service. So I'm going to say, in my example, I'm talking about Azure Storage. Now for those PaaS services, they are by default internet facing. I address them via the internet. And so the way this works is those services actually have a whole batch of IP prefixes, and they vary by region. So there's a batch of IP prefixes. A prefix is just a contiguous set of IP addresses. So in South Central, storage uses a certain list of IP prefixes. In East US 2, a different set. But essentially, there's all these IP prefixes that make up a certain service. And what happens is all of these different IP prefixes that make up the services, well, remember, they're internet facing. So those address spaces are basically advertised out to all those different internet services. That's what they're doing. Now we can actually look at those. So if I jump over for a second, and what I'm going to do is quickly just show you. So we'll often hear about service tags. So service tags is a feature that lets me make certain subnets in a virtual network known to that service endpoints to virtual networks. Service tags let me control from network security groups saying, hey, you can only access these services. Well, it does that by looking at what are the IP addresses that make up a certain service. So if I look at a service tag, I can get a list of, well, what are all the service tags? And then I can say, well, show me the service tag values for storage in South Central US. And I could list out what are all of the different IP prefixes. And as you can see, there's actually a lot of them. There's a whole batch of these. In fact, if we count them out, we can see there's 47 different IP prefixes that make up storage for South Central US. But fundamentally, it's just a big batch of IP addresses. And again, those service tags we use in network security groups to say, hey, my subnet or wherever I apply this network security group can only talk to these services, can only talk to these groups of IP addresses. And you'll see there's the same for things like SQL. So I was showing storage, but once again, SQL, well, it has its own list of IP prefixes, just groups of IP addresses. Now, sometimes you'll hear us talk about BGP communities. So BGP community is something we can kind of add on to the routing advertisements over BGP for a set of IP prefixes about what the service is doing, a friendly name for it. So we can then use that information, that BGP information, maybe to make routing decisions for traffic modeling, for example. And so we can see those same IP addresses I just showed you. If I actually go and say, hey, I want to look at the BGP communities. So if I get all of them for Azure, so there's quite a lot, I'll save it in a variable. And then I look at the one for South Central US. Well, once again, it's showing me all of those IP prefixes for South Central US. And notice it's exactly the same. Look at the first one, 1365.107.32. Well, it's kind of those same list of IP addresses. If you look through, you'll see they all match. So it's the same IP addresses that we're using over here as well. So those BGP communities are going to kind of tie up with the service tags IPs we have. So fundamentally, all we are doing here is there's a big batch of IP addresses, that's it, that we advertise out to the internet saying, hey, to get to these IP addresses, I'm going via the internet. And that's all it is. So there's different groups of IP addresses for different services in different regions. Nothing more than that. So now if I'm thinking about that, well, if I'm on premises, for example, so let's say I'm here, and I'm using a particular carrier. So I have an internet connection, let's say up to AT&T. So this is my internet path. Remember, I'm seeing that advertisement coming over that path. So if I'm now sitting there and, hey, I want to use that service, I try and go to something in storage, well, I'm going to take that internet path to get to it. It's that internet-facing path. And most likely, I've got kind of a NAT service at the edge of my network, because this is all a private IP space, doesn't work over the internet, so I NAT it. And so Azure sees that request coming from whatever NAT IP address I have at the edge of my network. If I actually try to look at a particular storage account, if we jump back over, so I have a particular storage account in my environment. So if we just try and look that up, we can see it's, 20.150 over here, .38.4. That is the IP address of that particular storage account. As that 20.150.38.4, I would see it, there we go. So it fits within kind of that IP prefix that I could see in the BGP community. And if I kept going up, I would see that same, there you go, 20.150.38 over there as well. So it's really nothing more than that. I'm just going to a certain IP address, which has been advertised down to me. Okay, so that's advertised to the internet. And if I wanted to, as I mentioned, I could absolutely kind of lock that down. Because if and this storage account, a particular storage account, which is what I was showing you there, well, I'm going to see the traffic coming from whatever NAT service I have at my edge. But I'm going via the internet. And I've drawn this nice straight line but it really wouldn't be. It's the internet. So it's going kind of all jaggedy all over the place to get there eventually. Okay, so where does ExpressRoute come in and Microsoft peering? So remember, what is ExpressRoute? ExpressRoute is the idea that I as an organization now have a private connection to connect me to the Microsoft backbone. So at these same edge locations, I could actually kind of drop lines, it could be to the same one, so maybe drop lines into my location. Now, there's different types. There's Ethernet layer 2, there could be MPLS, there's different ways, but essentially what it is now doing is creating a connection from my network to that Microsoft backbone. They're kind of doing a nice little cross connect for me in here. I now have a connection to the Microsoft backbone. But that on its own is nothing. Yes, I've connected to the network, but it doesn't actually give me anything. So then we have peering, and there's two types of peering. There's private peering, which is used to connect a certain IP space to another IP space, i.e. up here in Azure, I would have something like a virtual network. And that virtual network has a certain IP space, and private peering would enable me to connect my IP space to the IP space of that virtual network, because there would be kind of an ExpressRoute gateway in there, and it would connect them. And then there's Microsoft peering. So Microsoft peering enables me to connect to services that aren't in a VNet. Office services could be, but you have to get special exceptions for those. They're generally better served by the internet. I can get this asymmetric routing that breaks things because packets go out one way and they come in another, and it doesn't work. But those services like the storage, the SQL, the Cosmos, I can do those. And so let's focus on that. Let's focus on Microsoft peering first. How does that work with this? So in Microsoft peering, I create a Microsoft peer configuration on my ExpressRoute circuit. Now what actually happened, I drew these two lines, but absolutely before I do that, I would have a set of NAT gateways. Remember, Microsoft peering, I'm connecting to services that talk on the public IP space. So they don't understand a private IP space. So I would have a set of NAT gateway IP. So I'd kind of have this NAT IP range, which is all the NAT IPs of my gateways. Then I have a different set of IPs for the BGP connections between them. But what I get out of that fundamentally now is I get this Microsoft peering. So I now have this connection. But on its own, it's not really doing anything. Now, as part of that Microsoft peering, I tell it which addresses I want to advertise to the Microsoft network. And that would be that NAT IP range. They're the ones that are kind of that are internet addressable. I would never advertise these to the internet. They only get advertised to the Microsoft network. If they were also advertised to the internet, it can cause a lot of problems, because again, you get into that asymmetric weird routing scenario. So these are only advertised over that connection. But now I have to tell the Microsoft network, hey, I want you now to advertise certain services to my on-premises network. And we do that with a route filter. So if I jump over here, what we do is we create a route filter. And remember I talked about those BGP communities, those groups of IP addresses? Well, in a route filter, I select them. I can go through and select all of the services that I want to make available. For example, here I can see like Azure storage. Hey, look, South Central. Notice that community 12076:52, and it's longer than that, 5200 and an 8. That's going to match what we saw when we dumped out that BGP community. So essentially, when I tell it to dump out that BGP community, which we can see here, what it's now saying is, hey, it's actually all of those prefixes, all of those groups of IP addresses. And I can go and add multiple ones. I can basically go through. So I create the route filter, which is the list of all the prefixes I want to advertise over Microsoft peering, and then I attach it to that Microsoft peering circuit. So that configuration on the circuit. So now I created the route filter, remember, which was the list of all of those BGP communities, which was essentially all of those IP prefixes. And now, instead of only advertising out to the internet, well now, those IP addresses, because they're part of my route filter, they are now going to advertise down through my ExpressRoute Microsoft peering connection. And it's going to be a shorter path than that internet path. So now when my client wants to go to Azure storage in South Central US, because I'm advertising a path via my peering, which is shorter than that internet path, instead of going out via my internet connection, I'm going to go up through my ExpressRoute circuit. So that's all Microsoft peering is. It's simply saying, hey, those public IP addresses that normally are advertised out to the internet and still are, I'm also advertising them down via my ExpressRoute circuit, but it's going to have a shorter ASN path, i.e. the hops I have to go to get there, than that internet direction. So hey, I'm going to go via my ExpressRoute. And that's really it. That's the whole point of what Microsoft peering is doing. I'm selecting groups of IP addresses that I want to advertise down now through my ExpressRoute connection. And the cool thing you can do at this point is, remember, you control the NATing. I have to do that NATing on my side. So I know what those IP addresses are. They're the ones I'm advertising up through that Microsoft peering configuration on the circuit. So technically, if I had a particular storage account, for example, so let's say I've got my kind of, let's say storage account 1, I can absolutely modify kind of the network configuration firewall of that service and only allow in these IP addresses. So yes, it's public facing, but I'm saying the only traffic allowed in is going to come from these IPs that are the ones I'm NATing the traffic through that goes via my ExpressRoute circuit. So I can absolutely do that if I wanted to. Okay, so that's Microsoft peering. And again, I'm saying storage, pretty much you saw all the different services that I can do on that route filter. Just to give you an idea, there's so many different services available. All of these different types of service. You can see the backup, Cosmos, SQL, lots of other things all available here that I can actually control. So lots of different things there. And then some of them, you notice I saw Cosmos and SQL, they're the ones that allow me to granularly control. Then there are ones just, hey, I take the stuff in the region to push down as well. So that's Microsoft peering. Great. Advertising those public-facing IPs now through a private connection. Where does private peering, where does private link come into this story? So remember, the point of private link is you can take this service, and the whole point of private link is it takes an IP address from the virtual network that I'm projecting into, and that private IP address then points to a specific instance of the service. That's really all private link does. So it's private IP1, for example, points to storage account 1. So it's an IP address from the IP space of that virtual network that now when I access it goes directly to that particular storage account. Now that's one half of it. And if you remember, when I did a lookup for my storage account, you may have actually noticed something slightly weird. So if I jump back over, notice that, hey, it had kind of the regular name. So it's always like storage account.blob.core.windows.net. But for mine, and yes, it resolved to a public IP address because I'm on a machine that's just out on the internet. So it responded to that public IP. But it also had kind of this strange alias, and it had one to private link.blob.core.windows.net. Because this storage account actually has a private endpoint enabled. Now, what happens then is, so the DNS, I also have a special record for that private link variant that actually was resolved to the private IP address. So if I jump back over and we actually look on this machine, and on this machine I do exactly the same NS lookup command as I did on the other one, it resolves to a very different IP address. it resolves to its private endpoint IP, because this machine is on a virtual network that actually has the private endpoint DNS configured and resolvable. So the other half of a private endpoint is, yes, I have an IP on the network. Great. But now the DNS name actually has an alias, it becomes an alias to a private link variant of it. And I have to be able to resolve that private link variant. Now there's different ways I can do that. There's obviously services like Azure DNS. So I can have Azure private DNS zones. And it will offer to automatically kind of set up that private link .blob.core, etc. And it will add the record for, let's say, storage account 1. And it will add, well, hey, it resolves to that kind of private IP address, whatever it is. It will do that for me. So that's Azure DNS. And if I'm just using Azure DNS, hey, I really don't have to do anything else. That zone it creates would be linked to from my virtual network. So now I could just do a lookup and it would resolve just fine. Or I could be using my own custom DNS, and I can do one of two things then. If I'm using custom DNS, well, I could think about either, if I'm running my own DNS service, so this is my DNS box, I could either add a zone, private link, that whole big zone, .core, and I would add a record called storage account 1, and I would add in that IP address. So I have to now maintain a list. The IP won't change while that private endpoint exists, but now I'm maintaining my own records. I'm manually creating them. Or there's a special endpoint for this Azure DNS. There in any Azure virtual network, there's this special kind of 168.63.129.16. That IP is always the same on any virtual network in Azure. That is Azure DNS service. So if I was hosting my own custom DNS in Azure, so this DNS service is in Azure, so that IP address is resolvable, well, instead of maintaining my own record, my other option, or I could actually set up a conditional forwarder. And I could have a conditional forwarder. Conditional forwarder says, for this DNS zone, go and look up over there. So I could have a conditional forwarder, and I use the regular zone. I would use the regular kind of blob.core.windows, not the private link. So I would say for blob.core, etc. I want you to forward to the Azure DNS IP address. Again, that works because the DNS server is in a virtual network and can talk to 168.63.129.16. So we have choices. If we're using just regular Azure DNS, I don't have to do anything. It will offer to create this zone for me so it can resolve to that private endpoint IP address. If I'm using custom DNS in a virtual network, well then either I have to maintain the private link. I don't create the regular zone, so then I break accessing any other type of storage account, but I create the private link variant of the zone, private link.blob.core.windows.net, and add a record for storage account 1 and the private IP. Or I can say, hey, for blob.core.windows.net, I want you to forward to the Azure DNS IP. And that's what I'm kind of actually doing in my environment. I've actually got a custom DNS running. Okay, so that's great. What does that have to do with on-premises? Nothing. I'm sitting over here. Well, remember, at this point, this is now just an IP address. There's nothing special about it. If I actually go and look at my configuration, and so this is the storage account where I've enabled my private link. If I go to networking, and I go to my private endpoint connections, you can see I've created the private endpoint. I've created one for my blob and one for files. It's nothing more than just a network interface. I can see its IP configuration. And then that's that IP address that you saw my record actually resolved to, that 10.0.1.4, is what it looks like for something actually within that virtual network. So it's just an IP address. There's absolutely nothing special about this, which means, and this is where we get into, okay, private peering. So what does private peering do? Remember, private peering is nothing more than mapping an IP space to another IP space. So I could now say, hey, I'm doing private peering over this ExpressRoute connection as well to that ExpressRoute gateway. So now I've got an IP path from on-premises to this IP address, which means I can access a storage account. So if this is private peering now, mapping an IP address space to a VNet, and that VNet has a private endpoint in it, I can get to that from on-premises. Now I'm drawing private peering with ExpressRoute. This would work with site-to-site VPN as well. This is just an IP address. There's nothing special about it. But there's one caveat. Would this work as is? I can get to the IP address, but I won't be able to get to the name. Remember, I have to be able to get to that private link special name, which is not going to work right now. So I'd have really two choices. The same choices I actually had here, with a slight skew. I probably have on-premises DNS servers. So I have a DNS server here. So one option would be I would create those private link zones. So I'd create a private link.blob.core, etc. I would add a record for storage account 1 that would resolve to that kind of private IP address. And now I'm fine. Because when I did the NS lookup for storage account 1.blob.core.windows.net, it would be an alias now to the private link variant, which I can map to the IP address, and I now have a path to the IP address, and it's just going to work. But now I'm maintaining those records on-prem on my DNS, which is not a huge deal. Maybe I don't want to do that. So the other option is I do that conditional forwarding. So once again, we can do the OR. But I cannot conditionally forward to that 168.63.129.16 because I'm down here. That IP address means nothing down here. So if I wanted to do conditional forwarding, what I would actually have to do is I would create a DNS forwarder in my network. And this would have an IP address, let's say 10.0.1.20. And this would be configured to forward to the whole 168. I'm never going to remember this. 63.129.16. So that would be a conditional, that would be forwarding on this for kind of that, the blob.core, etc. So then that 10.0.1.20 DNS forwarder, and that works because it's in the VNet, so we can get to the Azure DNS endpoint. So then my on-prem DNS server, which has an IP path to 10.0.1.20, it could have a conditional forwarder for blob. And I used a blob, I used a full. And again, I'm doing blob. This could be SQL or anything else. That would now forward to 10.0.1.20. So hey, if I'm trying to get to blob.core.windows.net, finish right out, send that request to 10.0.1.20. So okay, that DNS server forwards it to this DNS server, 10.0.1.20, which you can get to because it has an IP path. It says, oh, I'm forwarding that same request to 168.63.129.16, which is Azure DNS that has the record. So it's a bit more convoluted, but it will get you there. I mean, it will have that path and it will work. So they're really my options when I think about, hey, my on-prem use of that. The benefit of this is there is no public endpoint. When I'm using the Microsoft peering, it still has public endpoints. Again, I can control it because I know those NAT IPs that I'm using for Microsoft peering, I can still control that traffic, but it has public endpoints, and some people don't want that. So with the private endpoints, I can essentially turn off all of those public IPs. Nothing goes public to the storage account anymore. I can only get to it from the private endpoint IP address. But now I use the private peering or site-to-site VPN to get to it. You just need to make sure the DNS. So either I add the zone for the private link, or I conditionally forward for the public part of the zone, which goes to a DNS forwarder in the VNet, which can then talk to the Azure DNS endpoint to talk to it. Now, a downside of the private link is obviously there's costs associated with that. If you think about, I have to pay for the private endpoint, which is, I think it's like a penny an hour or something, and I have to pay for the ingress and egress traffic. So I do pay for the traffic as well. Also, I'm paying for the ExpressRoute gateway, which now all my traffic is flowing through. I can't use FastPath today. So FastPath is where normally traffic going into the VNet has to go through the gateway. Egress never goes through the gateway. Ingress does. FastPath says, hey, I'm going to bypass the gateway and just go directly to the resource. FastPath does not work with private endpoints today. So if I'm using this to get to my private endpoint, I'm using up whatever capacity that gateway is. I'm using up a chunk of that capacity. So I'm paying for the gateway, I'm paying for the private endpoint, and I'm paying for the ingress and egress for that private endpoint communications. With obviously Microsoft peering, I'm paying for the egress traffic. Now maybe your supplier charges you separately for Microsoft peering over private peering. That can kind of vary by carrier. They're really the big differences between them, and hopefully that makes sense, what we're really doing here. Microsoft peering, we're just advertising those IP address spaces over your ExpressRoute connection. And so I'm taking that path because it's got a shorter path. And I can lock it down because I know the NAT IPs that we NAT the traffic to going via Microsoft peering. Private peering and private link. Hey, I'm connecting an IP space, so then I can get to the private endpoint IP, but I do have to deal with the DNS, either by adding a zone for that private link part and adding the record for the storage account or MySQL, whatever else, or I have to have a conditional forwarder to a DNS forwarder in the VNet, which can then talk to the Azure DNS endpoint. That's it. I hope that made sense. I hope that was useful. And as always, until next time, take care.